Welcome to Master Concepts in Chemistry. In this lesson, we will discuss how to calculate solution concentration in molarity. Mathematically, we can represent molarity as mole of solute divided by volume of solution in liters. Okay, so molarity with the symbol capital M is equal to moles of solute dissolved in a volume of solution in liters. Okay, so we are dividing moles of solute by liters of solution. So what you have to keep in mind is anytime at all you're asked to calculate molarity and the volume is given in milliliters, you have to make sure you convert it to liters before you divide moles of your solute by volume of solution. Okay, so as you've seen, solving for molarity is not that challenging if you really know what you're doing. Now, sometimes they won't give you moles directly. They'll give you, let's say, the mass of your solute, in grams. So sometimes they give you the mass of solute in grams and they ask you to find the molarity of the solution. So they give you mass of solute in grams. You have to remember that to get moles, you have to divide your mass of your solute by the molar mass to get moles. And once you get moles, then you then proceed to divide your moles of your solute by the volume of your solution in liters to find molarity. Okay, so that is something to keep in mind. Sometimes moles will not be given to you directly, so you have to figure it out. Okay, so let's look at some problems. This problem says you made 200 ml of solution of glucose that contains 0.3 moles of glucose. What's the solution concentration in molarity? So first of all, we have to recall our molarity formula. So I would write molarity in parentheses uppercase M is equal to mole solute over volume of solution in liters. Okay, so I just shortened volume of solution in liters. So this is what you need to recall. So once you recall this, you go back to the problem. So the problem says we have 200 ml solution and also we have 0.3 moles. So if you look at the formula, moles of solute is given because glucose is our solute. So moles of solute is given. Volume of solution also is given, but the thing is the volume is given to us in milliliters, not liters. So we have to convert the volume to liters. So you have to recall that 1000 milliliters equals to 1 liter. So once you recall, we can then go and convert. So we'll say 200 milliliters here. And then we have our liters on top and we have our mils at the bottom because we need liters, so liters on top. 1 goes with liters, so I write 1, and then 1000 goes with mils. Yeah, and close the table. So units on the diagonal will cancel. These 2 zeros will cancel these 2 zeros. So I just have 2 divided by 10, which is 0.2 liters. So you see, so now we've converted our volume to liters. So we just go ahead and then divide. So we say molarity uppercase M equal to our moles 0.3 divided by 0.2. So mole liters, these are our units. So when we divide, we get 1.5 moles divided by liters. So sometimes when you calculate concentration in molarity, you don't see moles per liter. So this mole per liters, we can transition it to uppercase M, which means molarity. So we can rewrite our answer as 1.5 uppercase M, which means molarity. So keep in mind that when you have concentration molarity, you can replace the M and then you have 1.5 moles per liter and then use that as a conversion factor. Okay, so that's something to keep in mind. So you can always use your concentration molarity as a conversion factor by replacing the uppercase M with moles per liter. Okay. So you see, so that is how to solve molarity problems when you have your moles and you have your volume in mils. Now let's look at another. So this is the second problem. This one says that you made a 200 ml solution of glucose that contains 54 grams of glucose. What is the solution concentration in molarity? So here again, we have to recall our molarity formula. So we have to recall that molarity, uppercase M, is equal to moles of our solute divided by our volume of solution in liters. Now, if you look at the problem, we have been given volume in milliliters and mass in grams, but our formula calls for moles and volume in liters. So we need to convert our volume in milliliters to liters, and we also need to convert our mass in grams to moles. So how do we go from grams to moles? So this is where you have to recall the mole concept. So to go from grams to moles, we need to use the molar mass of our substance. So our chemical is glucose. So the formula for glucose is C6H12O6. So once we know this, we then proceed to find the molar mass of our glucose. So I'll write MM depicting molar mass. C6H12O6 of our glucose is equal to 6 times the molar mass of carbon, which is 12.01 grams per mole, then plus the molar mass of hydrogen, and we have 12 of those, so 12 times 1.01 grams per mole, then plus 6 atoms of oxygen times the molar mass of oxygen is 16.00 grams per mole. So once we add everything, we should get about 180.18 grams per mole. Okay, so what this says is for every 1 mole of our glucose, it weighs 180.18 grams. So that is our conversion factor right there. So once we understand this, then we can then draw a table and then go from grams to moles. So we've been given 54 grams of our glucose, C6H12O6. So now we want moles of our glucose. So moles on top. So moles C6H12O6. Then grams at the bottom. So grams of C6H12O6. So we go back to our molar mass. What number goes with grams? 180.18. So 180.18 here. And what number goes with moles? 1. Then we close the table. So units on the diagonal will cancel. So grams will cancel grams. So we go ahead and divide 54 by our 180.18. So let's go ahead and do that. So if we do 54 divided by 180.18, then we get 0.2997 moles. Okay, so that's all we have, moles of our glucose. So now we also convert our volume in mils to liters. So we have to recall that 1000 milliliters equals to what? 1 liter. So we draw a table. We have 200 milliliters. So we want liters. So liters here, and then mils at the bottom. So 1 goes with liters, and then 1000 goes with milliliters. So this will cancel that. So basically, these 2 zeros will cancel these 2 zeros. So we're dividing 2 by 10, which is 0.2 liters. So now we have our liters and we have our moles. So we go back to our formula. So molarity, uppercase M, is equal to our moles of our solute divided by our volume of solution in liters. So our moles is 0.2997. So 0.2997 moles divided by our volume, which is 0.2 liters. So you see that. So once we divide, we should get an answer. So let's proceed to divide. So once we divide, our answer is 1.4985 moles per liter. So we can convert this to 1 decimal place. We just round it up to 1 decimal place. So this will be 1.5 moles per liters. So you see that. So that is our answer. Now, but usually you don't see moles per liter. So what we'll do is we transition the moles per liters to uppercase M. So we'll say 1.5 molar. Okay, and the M here stands for molarity. So molar, so 1.5 molar. That's the solution concentration molarity. So what you have to keep in mind is anytime at all you see molar by capital M by a number depicting molarity, that means that you can always use it as a conversion factor. So once I have 1.5 molar, I can rewrite this as 1.5 moles per liters. And once I do this, a conversion factor. Remember, it's 1.5 moles per 1 liter. So once I do this, a conversion factor, I can always use it to go from moles to liters or liters to moles. Okay. So that is that. Thanks for watching.